The automated diagnostics show green across the board.
Excellent. The flight system integrity is confirmed.
Check the readings on panel 4.
All systems appear green. The pressure is holding steady.
From the outside, everything in modern aviation seems to be moving toward a world where humans only stand watching, while most decisions are handed over to automation.
The displays inside the hangar continuously show data streams accurate down to milliseconds, making many people believe that whether humans are still truly necessary if computers can already detect every abnormality.
That question exists not only inside the maintenance hangar behind the terminal, but also inside every flight control center, where algorithms are becoming faster than the human brain.
Engines. The narrow-body aircraft with matte gray metallic surface reflects white lights, like a symbol of the absolute precision aviation.
But the deeper engineers move into the world of intelligent systems, the more they realize that there is an invisible limit machines still cannot fully overcome.
Aviation does not only need systems capable of calculation, but also humans capable of questioning those calculations. And from that moment, the central question of modern aviation becomes clear, that if automation keeps becoming more perfect,
under normal operating conditions, automated aircraft systems can process thousands of calculations within seconds to maintain stable.
Workers aged 22 to 25 inside the hangar only need to connect the aircraft to the central system inspection sensors to predictive algorithms can detect abnormal engine vibrations long before human eyes or ears can notice any sign of danger. In many modern flights, autopilot systems can maintain stable operation for most of the journey with almost no direct intervention from pilots.
Automation reduces errors caused by fatigue, stress, and emotional reactions during repetitive procedures.
That is also why modern aviation is considered one of the safest industries in the world, even as the number of flights continues increasing every year.
Inside the clean, quiet, disciplined maintenance hangar behind the terminal, operational procedures are standardized to the point.
Watching automated systems operate smoothly with almost absolute precision makes many people begin believing that humans are the final unstable element that should eventually be removed.
Some even argue that the future of aviation would become safer if every decision were handed entirely to artificial intelligence instead of relying on human emotion and intuition. But precisely when everything becomes too accurate and too stable, and the first doubts begin appearing inside the maintenance hangar behind the terminal, he realizes that sometimes the most dangerous thing is not obvious failure, but perfection itself, causing humans to stop asking questions.
Automated systems can process familiar situations extremely quickly, but they only remain powerful when the world behaves according to what was programmed beforehand.
Problems begin appearing when real-world conditions create situations that never existed within training data or original system assumptions. A small sensor drifting under rare weather conditions can cause an entire chain of automated decisions to rely on data that is no longer perfectly accurate. The telemetry is showing catastrophic failure indicators right here.
Yet the main system still reports nominal function. Which one is lying?
Computers do not truly understand the meaning of danger, but only compare data against predefined limits.
That means if danger appears in a completely unfamiliar form, the automated system may fail to recognize the abnormality until it is already too late. The narrow-body aircraft with matte gray metallic surface reflecting cold light inside the quiet space makes the entire hangar begin sensing the fragility.
Automated systems never truly understand context, but only understand the data models they were trained to process.
The core reason automation in aviation cannot completely replace humans is that every computer system operates based on predefined logic.
Computers can become extremely powerful in processing speed, but they still lack human intuition when facing situations that have never existed before.
Artificial intelligence does not truly understand what the aircraft fears, but only understands which data levels are considered abnormal.
Humans differ from machines through the ability to connect small, unrelated signs into an overall sense of danger before failure actually occurs. In many historic aviation situations, human intuition, experience, and flexible reasoning saved aircraft from scenarios automated systems were never prepared to handle. Workers aged 22 to 25 continue inspecting every detail around the aircraft because they understand that not every abnormality can be transformed into data by sensors. Sometimes a tiny, unusual vibration sound can only be detected through an engineer's familiar listening experience and never appears clearly enough.
Machines often answer quickly,
But humans are the ones capable of asking the correct questions.
That is why modern aviation does not treat humans as backups for machines, but instead treats humans as the final.
Automation reduces ordinary human errors, but when extremely rare situations or complex data contradictions appear, inside the clean, quiet, disciplined space behind the terminal, every system is designed to support humans, rather than completely replace human judgment. The most important truth about aviation automation is not that machines are becoming smarter, but that humans must increasingly understand how machines can fail. The narrow-body aircraft with matte gray metallic surface rests beneath white lighting, while engineers realize that the greatest. If viewed only through processing speed, computers far surpass humans. But when facing adaptation to situations that have never existed, humans still remain irreplaceable.
Machines always require past data to predict the future, while humans can imagine danger even when they have never seen it happen before. The female engineer, aged 22 to 25, explains that automated systems react extremely well to known failures.
Humans can temporarily accept uncertainty in order to continue reasoning, while computers are often forced to make decisions based only on programmed probabilities. Workers aged 22 to 25 continue operating around the aircraft with no logos and no markings, as a reminder that aviation has never been built only through technology.
The greatest danger is not machines making mistakes, but humans believing machines are incapable of mistakes.
Absolute dependence on automation can gradually weaken human flexibility, because people no longer regularly face difficult decisions themselves.
That is the great paradox of modern aviation, because the more technological support exists, the more humans must be trained to understand situations where technology can fail.
Aviation does not keep humans involved because of nostalgia or emotion, but because even the most complex systems still require an entity capable of thinking beyond data.
Technology was never created to eliminate humans, but to help humans see what they could never see before.
For instance, inside the maintenance hangar behind the terminal, workers aged 22 to 25 continue inspecting every small detail. The male engineer stands beside the matte gray metallic aircraft fuselage, looking toward the lights as though looking into the future of aviation itself. That future will certainly contain more artificial intelligence and more sensors and more automated systems, but that does not mean the role of humans will disappear.
Because the closer aviation moves toward perfect systems, the more it realizes that the most important thing is not creating a machine that never fails.
The narrow-body aircraft rests silently, a symbol that the most powerful technology is not technology replacing.
And ultimately, the greatest limitation of automation in aviation does not lie within machines, but within the reality that the final responsibility